This is the second presentation about .NET Interoperability. This time it's not a beginner session, so I will assume that most of you have quite some knowledge, not some, but quite some knowledge about .NET. I will be showing concepts which I will not always explain. I will kind of assume that you understand most of at least common .NET concepts. So welcome to the black belt presentation. Nobody wears a black belt, actually, so never mind. I will not introduce myself again, or maybe I should for those who haven't been on the previous presentation. I'm Vjero Slabavic. I come from Croatia. I'm an MVP for NAV, and I've been blogging for like 6 years, writing books, articles, etc., etc. Nothing memorable, unfortunately. Anyway, I'm not going to start this presentation with a joke. It's a very serious presentation, so let me just jump into agenda immediately. So what are we going to do here? First thing, I'm going to take .NET Interoperability, then I'm going to slice it to ribbons, and then I'm going to glue it all back together. So the purpose of this session is basically not to expose problems with .NET. It's not my goal. My goal is to make you aware of certain glitches or like hidden things which are not documented, which might never ever be documented, small problems that you will encounter as you go that might cause you a lot of headaches. So I'm going to also provide solutions for those situations. And I'm also going to give quite some tips and tricks as we go through those concepts. So what's wrong with .NET Interoperability? Does anybody in this room have a feeling that something is not quite right? Okay, well, at least 2 people think so, me included. So what's wrong? I could talk for 2 days like what's wrong with .NET Interoperability. There are plenty of things which don't work quite well. There are plenty of things which are missing and should be there. There are plenty of things which are working the way they shouldn't be working. So I've put just those that I could like think of, or actually which I thought were most important. At this session we're going to talk about quite some of these. Not all of them. Not all of them are equally important. But we're going to discuss those and see what are the problems and how to solve those problems. So for all the problems that I identified today, I will actually provide a solution. So it's not going to be rocket science. So I'm going to actually start with a very simple concept to explain like what's wrong. And then I'm going to build on top of that, just identifying one small thing which doesn't work right, and then solving that to get into another one, and then solving it to get into another and another and another. So the first part of this session is going to be about the strong type. So do you know what a strong type is? Anybody? Strong type is basically something that you all use. You're all pretty familiar with it. It means that every variable has to have a very specific data type, like integer, string, date, time, boolean, etc., etc., etc. .NET is strongly typed. CAL is strongly typed. And now let me ask you just a quick question. Would you ever write a whole piece of code just by declaring all of your variables as variant? Is there anybody who would do that? I assumed as much. So strong typing is a concept which basically forces you to use types for your variables and to actually obey those types, to always assign the value of specific type that the variable is of. .NET works like that, CL works like that, but the interoperability doesn't quite work like that, as we are going to see. So I'm going to take one simple class, or actually not a class, it's an interface, and I'm going to start from there to explain what's wrong and then how to fix it. Have you heard of Ienumerable? Have you used it? Okay. So Ienumerable is an interface which is useful for one simple concept in .NET. Who knows that? Who knows which concept? For each, exactly, for each. What is for each? It is an iteration. It's a loop which goes through a set of elements somewhere in like a list. Typically it's a collection, but many things in .NET are enumerable, and you can enumerate through them using this Ienumerator. So Let's start with taking a look at this loop. So this is what kind of loop? It's C#, by the way. It's a for loop. Do you write for loops? You do, yeah. Me too. What kind of loop is this? A for each loop. Okay. And is there any significant difference between these two? Do you think there is or there isn't? Like it's quite the same thing, or what's your impression? There are two extremely big differences. So the first is the count method of the Ienumerable interface, and the second one is element at. So why are these two slow? First, imagine that you have to go through a collection. Like, for example, I want to enumerate through all of you here and like give a present to each of you. So I could go and start my loop by saying for 0 to count, and then I do and count up to 173. And then in each step of that loop, I say I go to the first person and I give a present. Then to the second, 1, 2, and then give a present. Then to the third, 1, 2, 3, and so on. So every element at actually does a count to get to that position. That's what Ienumerable actually does. So it does that when you call count to see how many elements are there, and when you say element at, it also, every time it tries to find that one, or maybe store all of them in memory just to be able to provide you that specific one. On the other hand, the enumerator should work in a different way. Enumerator just has two things to think of. First one is the current position. So I'm here. I'm with this person now. And I don't care, sorry, but about anybody else. And I give present to this first person. And then I have one method, which is move next. And then I move. And then I give present to the second person. I forget about the first one. I'm still not aware about anybody else. I don't have to keep track about anything. So there are just two methods. First one is move next, which gives me true or false as a result. If there are no more people in the room, then it's false. If there are more, then it's true. And then I can move and move and move. So what we should do with this loop is basically, we should never do that. In CAL, now this is CAL, when using .NET collections, which are basically Ienumerable, all of them, we should do this. So we should first extract the enumerator from the collection, and then we should really do a while loop by using the enumerator to actually get access. Because depending on what kind of a collection you have, it's going to be a big, big difference in performance. Really big difference. Especially if you're accessing data or accessing files in the file system. Never do a for each loop, because the for each loop translates to the wrong way of doing the enumerator. So let me now explain why is this relevant. It's not just relevant because of the performance. Performance is a minor consideration here. Even though it might be a very big problem with performance, it's still a very minor consideration compared to what we're going to see right now. So let me show you the first demo. This time I've actually prepared all of the demos up front. I'm not going to type. One thing that we learned from lessons learned is that we don't learn from lessons learned. But I still learned that my keyboard doesn't quite work. So I actually have all the demos here. So here is a simple list. You already know what constructors are. You should understand this code. So I construct a list. I populate it with 3 numbers. And then I use the right way of going through the list. So I declare the enumerator, I extract the enumerator from the list, and then I do while loop. And in each iteration, what I do, I assign to this I variable, which I can verify that it's an integer. So downstairs there you can see that it's an integer. So I assign this current, whatever that is. Let's not go into that yet. So whatever this current is, I'm assigning it to my integer. And then I'm printing this integer on screen. Let's take a look if it works. So I run that and, okay, I first have to restart my client because I was in sleep mode. Okay. And then I'll run again. So I have 14, 3, and 8. Okay, so I've got 3 numbers that I've put in the list. I've nicely assigned them to this I variable. I is what? An integer. What is this current? Does anybody know what is this current? Object, exactly. So let's talk about system.object. That's a very important type. It's the root of the whole class hierarchy in .NET. It's quite literally mother of all classes. However, when we get to .NET Interop with CL, it's actually a stepmother, not a mother. So we have a lot of problems with it, as we're going to see. So let me show you the first problem with system.object. How does object actually work? The object works by, actually let me show the demo and then explain. So I'm going to my second demo, and here I have a list. Okay? So this list is actually a generic type. So you might know what generics are. We're going to get to generics just in a minute. So here I'm stuffing integers. So in CAL, I can do that. I can also compile this, so it compiles nicely. So I press F11, it does compile. In C#, this doesn't even compile. Or actually, it shouldn't compile. Because if I have a list of integers, I shouldn't be able to stuff a string in it. And here I have a string which says, I dare you. So what do you think? Is it going to run? Yes, it will run. Why is it going to run? Courtesy of system.object. So we have 14, 3, 8. Okay, then I had something like this. So what happened here? So what's the problem? The problem is that here I have an integer. So what I'm trying to do is I'm trying to cast this object into an integer, and I cannot do that because this object is not an integer, it's a string. So strong typing kicks in, and I have to do something. So I could make a workaround. I could do something like this, just printing the enumerator without assigning it to a variable. Okay, another instance, never mind. Let me close this one then. I don't need to. So 14, 3, 8, and then I dare you. So it actually works. It does allow me to stuff a string into a list which I at least believe was list of type integer. So what is happening here? Before I explain exactly the mechanics that are happening in the background, let me show you a very rude code unit. A really, really rude code unit. Actually, I have a slide which is missing here. I apologize. So let me explain this concept first. The mechanics which are actually at work here are called boxing. Boxing is a capability of .NET to actually stuff anything into an object. Actually, you have 2 kinds of types. You have value types and instance types. Instance types are simply cast to object because it's on top of the object hierarchy. So every class can be cast to system.object. However, integer, for example, or decimal or boolean, they are not instance types, they are value types. So how do we assign those to system.object if they are not a class? So that's where boxing kicks in. So what does .NET Runtime do? So it takes this integer, it stuffs it into memory location, actually protects that memory location, creates a pointer to that memory location, and puts that pointer into system.object, because system.object in fact is a pointer. So what happens is we take an integer, we stuff it or box it into memory location, then place that memory location to system.object. So it sounds nice, it's pretty versatile, like you can do crazy stuff with this, just as I did here. But the problem is that it costs you. It costs on execution time, and it also is prone to errors. And also CAL has some funny or interesting or annoying features around boxing. So let's take a look at this rude code unit. We have seen already on this example and on this example that we can cast anything into object by simply calling the add method. The add method accepts object as a parameter, and also by casting the object to a variable, we can unbox something into any kind of variable. In fact, if you want to know, system.object fully maps to variant in CAL in 2013. So let's take a look at this root code unit. So here we have one simple function which doesn't really do anything, it's just very root. So let me show why. So this function does something with an object variable, which means I should be able to pass anything into it, right? Well, not quite. So let's take a look. Here, I'm going to declare a variable of type integer, okay? And then I'm going to call very root method with integer. So I should be able to box that, right? But when I try to compile that, I get a funky error. Assignment is not possible. So what to do now? Okay, let me try another thing. Let me take system.object type and then declare that as a local object and then say local object. I pass that one, it compiles nicely, but if I try to do that, local object is integer, it again refuses to compile. Okay. Let me try something else. Let me declare this integer as actually .NET integer, so int32. And then I say that I pass int32 into this. Okay, it still compiles, but if I try int32 is my integer, again, assignment is not compatible. And here, you stumble to a situation which you cannot resolve. There is no solution to that. And this happens with basically every single simple data type that you have. Integer, long integer, decimal, date time, boolean, etc., etc., etc. Whichever type maps directly between .NET and CAL, you cannot do this concept with it. And there are plenty of functions in .NET which do expect you to pass an object into them. So if you want to do something like that in CAL, you are stuck, and there is no solution to that. And the problem is that the compiler is probably trying to consider your variable as variant, trying to pass something into it, and simply fails at that. So let's take a look at how to solve this problem and many other problems which stem out of this one. So we have seen the root code unit. We have seen that boxing sometimes works, sometimes quite doesn't. So what we should do, actually, we should try to replace this system.object with an actual data type as often as possible. We should not use system.object because, as I said, system.object equals variant. You will never write programs just by declaring variants, just because it's simpler. It's not. In the end, it's going to cost you much more in terms of debugging and everything. So let's take a look at one nice idea which fails. So what I'm going to try to do with my enumerators is, first I'm going to show you the demo. So this is my demo. In this demo, I have one class which I have built in Visual Studio. It's called forEachHelper. The concept of this forEachHelper is to return a strong type for the enumerator. So if I have a numerator for integers, it's going to be a numerator of integers. If I have a numerator for like list of strings, it's going to be a numerator for strings. So it should always return the strong type. Let me show how it looks. So in Visual Studio, I will open this forEach class. It's a very simple class. It's a generic class. So it is constructed with a type, and then it keeps track of the enumerator. Then it has this forEach function which receives the enumerable, and then from that enumerable it converts this current to this declared generic type and returns it as this strong type, not as system.object. So when I call that here, since I know that my list is actually a list of type object, what I want to do is I want to cast this as object, because casting object to object shouldn't even be a casting. It should work just every time. So if you want to assign an object to an object, it must work. And even though I've done everything to make it as strongly typed as possible, when I run this piece of code, so what I do here is try to enumerate through the collection. So I get the first number, and then I get an error. Because runtime goes crazy. Okay, so again, no solution. So the only solution for this problem is reflection. So I will explain it just in a minute. The true solution should be to not use any collections, any generics based on system.object. And in fact, there is no way to declare a generic of an actual type. Have you ever tried to create a list of type integer in C#? And have you tried to do that in CAL? Did it work? No. So how do we do that? How do we solve it? We must have a way, like a workaround over that. So one workaround is to simply wrap everything into your own assembly, then reference that assembly, and then have that assembly, for example, return an actual strongly typed generic. That's a possibility. Why not? But then you must recompile it for every single generic type that you want to use. And the more you program, the more of them you will find useful, the more of them you will want to see in your code, and then you will have to recompile and recompile and recompile every time. So let's not do that. Let's go for some feature of .NET which is called reflection. Have you heard of reflection? I assume you have. So reflection allows us to see into the content of any type in .NET, to see what it can do, and to actually dynamically executing or utilizing the functionality of that class without directly calling the methods. Like if there is a method called add, we wouldn't call object.add. We would instead extract the method info for the method which is called add, and then we would invoke this method info object with parameter of the source object. So that's how reflection works. Reflection allows us to actually construct on the fly any type if we know either its name and the assembly where it resides, or if we know its type. So since we do know the type of our generic variable, what we can do is we can actually construct the generic on the fly. So let's take a look at what we can do with reflection. So actually I have pressed the wrong button. We have this type which is called system.type. System.type gives us every possible information about any kind of type in .NET. So this is the core of reflection. And then we have a class which is called system.activator. So system.activator creates an instance, among other things, of a specific type. So what we need to do is call this createInstance method and pass a system.type variable, and then activator takes a look at that type and constructs a variable of that type for us. So let's try to see how system.activator works. So I'm going to the 5th demo, and here I have a string builder. So you might have seen string builder on my presentation yesterday. So here I'm not calling a constructor, I'm calling activator. So instead of constructing it like typing string builder equals string builder.string builder, what I say is string builder equals system dot, or actually activator dot create instance, and then the type of the variable that I want to construct. The type is returned by calling the get.net type, and I'm passing this string builder into it. So when I execute that, my string builder should be instantiated. And then I should be able to append something into this string and then see if I have that content inside. So I can run that and verify that, yes, it works. So this was system.activator. So it's quite handy. You can do whatever you want with it. Just create any kind of type just by knowing the type itself. But it has some problems with generics, because generics actually have two types of type. First type is the declared type of generic. It doesn't do anything. So the declared type of generic behaves like kind of a hybrid between an interface and a class. So it tells you what a type can do, but the actual type is constructed either at the compile time in C# or at the runtime when you instantiate, or actually when you create a generic type of specific. So let's take a look at a simple type which is list T, or any other which has just one generic type. So list T is a type, but we cannot call activator to construct for us one list T. What we must do is construct, for example, list int32. But we cannot do that. We need to get to the type of int32. And in CAL, there is no way that we can declare that type, because CAL doesn't let us do that. So what we need to do is first, from the generic, from this blueprint type, create the generic type, which actually compiles it in memory for us, and then instantiate from that type. So it's kind of tricky. But it's really not rocket science. So let's take a look at actually how to use strong type generics in NAV. So here, what I have is one helper code unit. I've called this code unit generic management. And when I need a generic type, such as, for example, list, as I have in this example here, then I pass the object that I want to instantiate, and I pass the types from which I want to instantiate that object. So here, since I have only one generic, I have create generic instance 1. I have prepared create generic instance 1, 2, 3, 4. So up to 4 types. You can, if you want, you can easily support 5 or more. I've never seen such generics, but maybe. Who knows? So here I instantiated. Let me show how this class looks inside. So I'm going to definition. It's really, it's really not a big deal. So let me explain what happens here. There are 3 steps. First step is to construct the array of types. This is the array of that many elements as there are generic types being used by this generic class. So in this instance, create generic instance 1, I have 1 element, so I create an array with only 1 element. And then array is of system.type, because it contains the types that I want to pass into my generic. So what I do here is I pass the first type, the one that I have passed as a parameter to the method. Okay? So here I pass that. I construct the array, and I stuff this type into the array. If I have 2 types, then I stuff first and then second. Okay? The next step is to get the .NET type from this instance variable. So instance variable is at this stage list t, and I don't want list t, I want list int32. So here I get this list t, and then on this type, which is again system.type, very powerful type, I call make generic type and pass this array which specifies which types. I kind of lost you, right? Never mind. So just trust me on my word. So here what I get is an actual, this type of instance is actual list int32, not list t anymore. And now I can call activator to construct that. What this make generic type does is basically it compiles this, constructs it, or to be more precise, emits it, and then compiles it so that I can use it. And then I'm actually getting a true instance of int32. So this is how to create a strongly typed generic in CAL. So let's take a look at this piece of code. Now here what I do have is list of type integer. So will this code compile? Yes, it will compile, because CAL compiler is not that smart, unfortunately. It compiles, but it doesn't run. So if I try to run that, this I double dare you will fail. So here I have a type mismatch between string, which I'm trying to stuff into a strongly typed list. So now we have made a good first step into actually enabling the strong typed system. So this error is good. You want this error to happen. You don't want your generic lists to be to have like different types of data in them. The reason why you don't want this inside is because iteration is just one thing that you do with the list. So remember this demo when I have stuffed 3 integers and 1 string, and I made it run. So let me run it once again. It works, right? But iteration is rarely the only thing you do with collections or with generics in general. So, for example, you might call a method like list.sort. Okay? So what happens if you run that is that you're trying to sort apples and oranges. So there is no way to compare strings to integers. and it fails. So this is just one of the examples where it fails and why it is important to have strongly typed generics. Because here in the other class, which is strong type generics, so if I comment this one and call list.sort and run that, I actually see it sorted. So the point of generics is to actually enable strong typing. And what CL does to you is it forces you to use weak typing and then puts a lot of problems in front of you to solve. So here we have at least resolved the first problem. So we have actually instantiated a strongly typed generic. So let's take a look at another thing. So remember that enumerator.current. So this enumerator.current actually returns object. But I've written that for each helper, which is generic itself, so it should return the strongly typed enumerator. So let's take a look at that one. So the same nice idea that failed previously because I couldn't instantiate a strong type generic, here it works. So what I have here is I first construct a list of type integer, and then I construct the for each helper of type integer. And here, basically this for each method, I pass an integer into it. So not object, this is integer. So when I run that, it's actually working only on integers. So I couldn't even try to put some other type of variable. So it's keeping the strong type in place. And this is how generics are used in C# or Visual Basic or any other .NET language for that matter. And this is completely outside of our reach in CL. So now you know how to solve this problem. This code unit is already on my blog. I will put it again together with all the contents from this conference. So if you are interested or if you want to learn more or use that in your systems, just go ahead. So that much about system.type or actually strong typing. I will not take questions now. I will just, if you have any questions, please keep them in mind. I'm pretty sure there are quite some. Let's go to the second topic of today. It's error handling. How good is NAV at error handling? Pretty strong, right? How many different facilities do we have for error handling in NAV? Sorry? We have really one. So we have one facility, and that's if code unit run. That's the only thing which can actually catch an error and let us continue with return value of Boolean, and then we can check get last error to see what has happened. So this is the only thing what you can do. So if you have any kind of call in NAV that can fail and you want to intercept that, you must stuff that into code unit, which means whenever you encounter something new, you need to write a new code unit that you want to capture. And if you want to capture everything, then you will soon run out of code units. So let's take a look at a typical example because of which this is relevant. So what I'm going to try to do is use .NET to delete a file. So I'm taking, sorry? Oh, apologies. So here I have one file. Let me show that file. The file is here. It's called foo.txt. And here I basically want to delete it. And when I delete it, I print done. However, I have protected that file with security permissions, so this actually fails. And this is a typical situation in .NET. In CAL, for practically all input-output methods, you have one type of return value, which is Boolean. Like if you want to delete file from by using erase method, then it returns Boolean to tell you if it succeeded or not. And then you can check why or why not. Because in NAV there is no error handling. But in .NET, you never, or actually extremely rare, but I can't think of any example specifically, it never happens that you have a method returning true or false if it succeeds or fails. Because that's not the concept of .NET. In .NET, you have error handling, you have try-catch concept. So when you want to detect an error, you put it into try-catch block, and then it works. So if there is an error, the catch block fires, and you handle the error. And that's why most of the functions in .NET actually don't return true or false. They are void, which means they don't return a value, and then you intercept an error if you want, or let it bubble up if you don't. So this try-catch concept is very interesting. In .NET, basically every application uses a lot of it. And since we want to interoperate with .NET, we now have a problem, because in NAV we cannot handle errors. So the only way to handle errors, including .NET, is to actually put the code, which is .NET relevant, which might fail, into a code unit and call it with if code unit run. And then it fails. And code unit returns false. And then we gracefully continue. That's the only way. But again, if you want to do that for every single .NET function that you use, again, you'll quickly run out of code units. So this is not the right way to do that. You cannot just structure your code into code units that you call with if code unit run. Because code unit run doesn't quite give you a lot of context into what's happening. So let's take a look at a try-catch demo. So what I'm going to show is a possibility to actually intercept an error and respond to an error. So here I have a class which is called try-catch. Let's take a look at the class. Okay, it's a little bit long, so it contains a lot of functionality, but not everything is important. So the function is called try-catch. The function receives the object, so the object that has a method, then it receives the method name that you are invoking, and it receives list of type object intentionally, because you will see later why it has to be list of object. It receives the parameters that will run on that method. And then this class has two events, catch event handler and finally event handler. And it also has two more functions, try catch finally, which means like it will have both catch and finally block, and it has try finally, which has try and finally blocks, but without the catch block. And then I have overloaded combinations of these three for static methods. So you can also call them on static classes or call static methods of instance types. So try catch, again, this time I just passed the type in, not the actual instance. And then I, again, have the same try catch finally, and try finally. And the engine of everything is this run method. So what it does, it uses reflection, so it gets a method using reflection. There is just one method called get method. I've made it a little bit complicated because I wanted to handle various situations, because I wanted to make it useful. If somebody is going to download this from my blog, I really wanted to make it useful. So this handles most of situations, like with interfaces, with static methods, with static members of instance methods, basically many situations that are simply not supported in NAV. So, for example, you have very useful function string.join. You cannot call it because string is fully mapped to text, and join is a static method, and you have a problem. So with this concept, you can even call these things. So basically, what I do here is I get the method from the object or type, and then call that method on the instance for an actual instance, or on the type itself for static members or static types. And that's it. And let's take a look in NAV. What happens in NAV? What I have here is this try-catch object. It is with events. And then I have two events, catch event and finally event. So catch event says caught an exception and prints the exception. And finally just says finally. So the point of finally block is to clean up anything that remains after an error. So in C#, it's a very interesting concept. So you may decide not to handle the error, like you want the error to pop up on the user's screen, but still do some cleanup. That's what finally block does. So it fires even though there was an error. So even that is supported here. So let's take a look at different situations. So I will start with instantiating this try-catch helper, and then here what I do, instead of calling just f.delete, what I do is I create a list. This is a blank list. This delete doesn't receive any parameters. So what I simply do is call the delete method with empty parameters. So I cannot pass null. It must be an empty list, actually. And let's take a look what happens with try-catch. variation of this method. So I run that, and here I see caught an exception, and it tells me which exception. And it says done, because here after try catch it continues. That's the point of try catch. Let's try this, try catch finally. So I run that, and then I have caught an exception, and then done. Actually, sorry, I think that the object listener didn't pull the latest version. Let me run it again. So try catch finally. So I have caught an exception finally. It happens before you get out of the loop, and then done. And the last one is if I decide to not catch the error, but respond to clean up whatever mess this error might have left. So I save this and run that. What happens is I first get finally, okay, the cleanup happens, and then it crashes. It tells me it couldn't delete, so access to the path is denied. And that's it. So something that you couldn't do, now you can. So try catch in CAL. However, it only works with .NET calls. I was discussing with Thomas, I don't know if Thomas is here, I didn't see him, the possibility of actually make CAL methods or functions delegable, which would actually enable me to actually try catch any kind of exception, like apart from everything else that it would solve. But it remains to be seen if Microsoft decides to do that. Okay, let's go to the third demo here, or actually, third part, which is dependencies. What are dependencies? Do you use dependencies when you program? Do you create dependencies? Does anybody create dependencies? Okay, and the rest of you, I guarantee that you do create, and I'm pretty sure that you create more dependencies than those folks who put their hands up. What is a dependency? Dependency is one piece of code which depends on another piece of code. And if this another piece of code is not there, and not there in exactly that way, the first piece of code doesn't work. So that's a dependency. So now let me see who writes dependencies. Yeah, everybody does. So we all do. CAL language and C-side environment, unfortunately, forces us to have heavy dependencies in them. Who is familiar with PRS concept? Who has been today at Partner Ready Software presentation? Okay, so you are familiar. So what PRS is trying to do is actually raise awareness of dependencies, among other things, and other best practices, but dependencies especially, because any dependency that you create is causing you problems for development, for maintenance, and for upgrade, at least for those three, and maybe more. So dependencies are bad. Let me show you an example of tight coupling. So something that really has a very heavy dependency. So what I'm going to do here is import an object. So I will import table 18 ugly. Okay? So what does this table 18 ugly do? I've decided to implement for my customer possibility to log events in the event log. So my customer demanded that, and I said, well, .NET Interop allows that. So in every trigger in customer table, I have added this event log, write entry, and then the entry itself. And then I've written the same piece of code in the on modify and then on delete, and then the same thing in all 1,500 tables. So that's a very ugly dependency. I hope you agree. Is there anybody who disagrees with that? So is there a better way to do that? So actually, let me compile this table and let me run to see if it actually works. So I will start my event log, event viewer. Here I have some events from earlier while I was testing. So okay, they are gone from the screen. So what I'm going to do here is create a new customer. And then call it, for example, Tech Days Then click OK. Locate it in the list. It's there. And then I can verify my event log. So here I have two events. User this has created customer that, and then user this has modified customer that. And then if I delete the customer, I'll get an event in the event log which says user has deleted. So it accomplishes the goal, right? But it causes you a lot of problems. What if, for whatever reason, you cannot write to event log? What if the customer suddenly decides, we don't want event log, we actually want SQL Server logging, or we want file system logging, or message queue logging, or whichever kind of logging? What then? Then you have to replace thousands of lines of code which are actually the same line of code in thousands of places, which is ugly. So what I'm going to do here is introduce PRS concept. I'm going to call it PRS.NET. And I'm going to explain two things. One which is not really what PRS recommends, and one which is pretty much what they do. So let's take a look at the first demo. Actually, I wanted to import the less ugly variation of this code unit, this table. So I'll import this table 18 less ugly. Let's take a look at what this table does now. So here I not only have the table, I also have a code unit. So I will replace all. And then let's take a look at this code unit. So first I have the code unit called tight coupling, but it's less tightly coupled than it was earlier. So here I have a method called log, which actually writes an entry into an event log. Okay? And then in the customer table, what I have is, I'm calling this code unit, as you can see down there. I'm not calling event log directly. So I call my event log code unit, I could call it like any logger, and then call this log method. And then if I want to exchange that, for example, with SQL Server, or with, message queue, or file system, or whatever, how many lines of code do I need to change? One. Just one. Or maybe 5, replacing 1 with 5. But I don't need to touch thousands of objects. I can keep them alone. So, is this okay? I see this. Is there anybody who thinks it's good enough? Okay, it's not quite good enough. We can do better. So, let me do it the PRS.NET way. So what I'm going to do here is implement the facade pattern, which is one of the patterns that are really propagated by PRS. And if you have listened carefully to yesterday's keynote by Thomas and Michael, you might have noticed that they have also mentioned facades and hooks. So what I'm going to do here is quickly explain what the facade does, and then show how to use .NET Interoperability to help you with that. So let's take a look at a different version of this customer table. So I'm importing the facade version of the table. So here actually I'm just replacing this one. I will skip everything else because I have the objects already in the system. So I'll click OK. And then let's take a look at what this table customer does. So in table customer, I have a function which is called write log entry. And it says created. Okay, I really couldn't bother to translate this to the text constant, primarily for the reason I wanted you to see what it does. So here I say write log entry created, here I say write log entry modified, and here I say write log entry deleted. Okay, so far so good. The next thing is this write log entry method. What does it do? It actually uses a table, and this table is facade event facade event arguments. And here I have 3 fields. First field is method name, so which method I'm calling. The second one is the name of the argument that I'm passing into that method. And the third is the value of the argument, which is blob, which means I can put anything into it. It's binary. So I can take something from memory, stuff it into this blob. And that's where my .NET is going to help me. So what else do I have here? I have the facade setup table, which tells me, like, for this user, for this method, handle this specific type of call with this code unit. And that's it. Okay? So let's take a look back at the table 18. What I have here is I use this facade arguments management. It's really nothing fabulous inside. I initialize the writing of the parameters. So I'm just saying, like, I'm ready to stuff more parameters into it. So I specify the name of the method. So it's the name of the method is method write log entry. This is a function. Actually, let me show the function. The function simply returns the text, which is write log entry, so that I have global repository of all the constants which I use in the pattern. And then I create an entry. So this is what I'm going to print into whichever kind of log. I don't care which kind of log that is. And then I write the arguments. So what I do here, let me actually take a look at this write argument. I'll go to definition. So here, I instantiate an instance of key value pair. This is just a helper class that I created, but I could have done differently. I just made it to make it simpler. And then key value pair.key is the name of the argument that I'm passing, and value is the data, which is variant, which is actual system.object. And then I put that into this args write, which is a list of type object, which means it accepts anything. So I don't care what type it is, it will accept it. So here, what I put into this list is this entry, the text that I want to print. And then I call finalize write. And what does this do? It actually serializes my list of arguments using .NET into this blob field. Okay? And keeps this, actually clears this list for future use, and has this event args, which is table, which is actually a temporary table with this blob field containing all of the arguments. Here I have only one. I could have thousands of arguments. For example, a method which accepts thousands of them, I could stuff thousands of them and serialize all of that into this blob. Then what I do is I call the facade. I call facade.run, and this facade.run is basically code unit called demo facade. Let's take a look at what this code unit does. So facade.run first finds the method. This is a simplified facade pattern, just to note. So find method checks for my user account and method name, which is stuffed into that event arguments table, and it locates the code unit. And if it does locate the code unit, it keeps the ID of that code unit here. And then if it cannot find, it gives me an exception. It tells me no facade code unit defined for this method. And then I run this method. I simply call code unit.run, and then this code unit runs. And I pass this event arguments, which is this temporary table, into this code unit run. And now I can really use this config file to replace. So let's take a look. Here in my facade setup, I have code unit 5014. Let's take a look at what 5014 is. It's facade file system log. Okay. So it has on run. It initializes. So let's take a look at what initialize does. It simply reads the arguments from the blob into this arguments list. Then I implement the facade, which has a case block, which for each method that this code unit supports, it first checks if I have arguments for that method in the blob. If I do, it reads them from the blob, and then calls the log entry function, which is a specific log entry function. It is actually writing to a text file. So let me create a new customer. So here what I'm using is this temporary folder. So when I create a new customer, test, close, here is my event log. It has 2 events already. And then I say delete. Oops, the wrong one. Never mind. I could have deleted it. It's not my customer production database. So I have another event deleted. So what if I'm not happy with this? So what if I want to replace that with a different? So what about this event log? So this is also utilizing this facade pattern. So here I again receive this facade event arguments as parameter, and I do the same thing, except that I call event log write entry. So there is 0 lines of code to replace. What I go and do is basically just run this facade setup and take a different code unit number. So here I will actually populate it with 50,012, close this, create a new customer, and my file has not changed, but my event log has. So here I can see that I have user this has created customer that. And then I can delete this customer from here, and then I will have a new event, or actually modify first and then delete. So this is basically the PRS facade pattern with a little help of .NET, which makes it kind of more flexible and more powerful. Okay, but you might have imagined there is a better way. Can anybody tell me what would be really the correct way to handle this situation? How do we do that in .NET? Is there a pattern which we use in .NET? Sorry? Interface. Yes, we use interfaces, but we use a specific pattern with interfaces, which is called inversion of control. So what does inversion of control do? It depends on interfaces. We have an interface which defines a blueprint for whatever class. The interface says what a class can do. And then the concept of inversion of control is to supply the actual implementation of the type of the interface at the runtime. So something very similar to that. It's just that its facade is on very close to being like inversion of control. It's a very weak type of inversion of control. So when you need to create an instance of a method in .NET, an instance of a class in .NET, what you do is you do not call the constructor of that class, because that constructs a very specific class. What you do is you know the interface that you require. And then instead of constructing a class which implements that interface directly, you call this inversion of control framework, whichever that is, and you say like, I need an instance of this interface. And then inversion of control gives you the instance. And then depending on how powerful this framework is, it might return you a static, a singleton, or like whichever. Like there are plenty of things. But the point is that it's not your code who is deciding, it's somebody else. It's total decoupling. So you decouple all of the code. So let's take a look at how could we do something like that in NAV. So things like that are completely impossible without .NET. So you cannot even think of inversion of control without .NET, because you really don't have interfaces. This facade pattern is the best you can do, because you don't have a generic way of calling something, except by using this code unit run and then having the same blueprint that all of the code units that belong to the pattern support. So here we have a different approach. So what I'm going to do is I'm going to show this iLogger interface. It's a very simple interface. It has a single method, which is called log, and it accepts a single parameter, which is of type string. So what I can know from this definition of the interface is that I will have classes which support logging a message. And how they log a message, I don't care. It's my inversion of control framework will care of that, not me. So I also have two instances, or actually two classes, which implement this interface. I have this event log logger, which writes to event log, and then I have file system logger, which is also iLogger, and it logs into file system. Let me import the inversion of control version of table 18. So I'll replace this one. I will skip all the others because I have them already, and I'll click OK. So here in table 18, now we have a lot simpler code. We have write log entry created, so this one has remained as it was with the facade pattern. However, this one is much simpler. What I have here is IOC. This is my inversion of control code unit. This is my inversion of control framework. And then here I call a method called write event log. So this framework knows of this method, but at this point I don't have a clue how exactly this log entry will be written. I know that it will be written by somebody, somewhere, but I don't care by whom and how exactly. So let's take a look at what this write event log function does in this code unit. So I'm going to definition. I have two simple calls, very simple calls. First one is dependency management code unit, where I say get dependency. So this logger is a local variable of type iLogger. So this variable itself doesn't do anything. It's just an interface. You cannot have an instance of an interface. But you can have a class which implements an interface and cast it to this interface and then use the interface directly to call the methods on whatever that class is. So what this interface does, as I can verify here, this logger has one method which is called log. Doesn't have any properties, doesn't have any constructors. I cannot construct that. But my dependency management code unit has this get dependency function which will return the dependency. So how does it return the dependency? It looks up in the table. So here I have dependency setup table, similar to the facade pattern, where I have type name. So here I have to enter the type that I want to control with this inversion of control pattern. So I know that the type is called NETTechDays2013 and then iLogger. This is my type. Let me just be extra sure of that. So TechDays2013 iLogger. And then assembly name. So I have to provide the assembly which handles this iLogger interface. Here I'm going to pull a trick out of my sleeve, but then I'm going to actually reveal the trick. So I'm copying this line of code here and pasting it in there. I will explain what I did in a minute. And then I'm specifying, so this is the assembly from the global assembly cache, which actually contains classes which can handle this interface. And here in the class name, what I do is I actually specify the exact name of the class. So let's take a look at this one, file system logger. So I type TechDays2013.filesystemlogger, okay? And I close this page. And let's take a look at what else happens in this dependency management. So first, if you remember, here I had get dependency and I have simply passed the variable into it. Okay? Now, if I go back into this get dependency, what it does, it gets the type of that variable. And this type actually matches the setting that I had in my, let me put the table back on screen. The type actually matches this string, TechDays2013 iLogger. Okay? That's the type name. So I first get the type here. Then I have one dictionary, which is generic, strongly typed dictionary, where the key is system.type and value is system.assembly. Sorry, system.reflection.assembly. So this dictionary basically caches all of the assemblies which it loads dynamically. So I can dynamically load a DLL now in NAV using .NET. So here I have this assemblies, this is my dictionary. If I don't have that, basically if it's null, basically if it's the first call to this framework, then I construct it using my generic manager. So I construct it from system.type and system.reflection.assembly. And then here I get this dependency setup table by passing this name of the type. So if this fails, I get an error, because if I can't handle the dependency. If it succeeds, then I have another one. If I have this force refresh flag, it will actually reload the assembly, even though I have it cached. If force refresh is not switched on, then it will just skip right to here. And then it checks, do I have this assembly, or actually this type in my assembly cache? If yes, then I get it from the cache. Sorry, I apologize. If I don't have it, then what happens is I re-get this. This line is actually redundant. I don't need it. I load the assembly from the global assembly cache, and then I add it to my local assembly cache. And if I could find it in my local assembly cache, I just take it from the assembly cache. And here I call the create instance method again to create the instance of the class which I've configured in here. So let's take a look at how this magic actually works. So I'm going back to my customer card, creating a new customer, closing it, and then refreshing, and then deleting the customer. Oops, not that. This. So delete, yes. And let's take a look at my file system. Did I use event logger? Oh, just a second. Let me close the client. Maybe it used some kind of caching. Let me close all of the objects which I have open, so just in case. Sorry? It shouldn't be that. Let me see. So here I have user has just done that, and then I have my inversion of control, which says it logs this. Let's put one space, and let me run it again. So I create a new customer. Close it, and then I think it should be, oh, yes, that's right. It's not this file, it's this file. It was logging all along. Just the different file name was used here. I apologize. Thank you. I didn't catch what you were actually trying to say. So now it writes to a file. So what if I want to exchange that for event log? I simply go to this setup, dependency setup, and then change this class from file system logger into event log logger. Okay? And then create a customer. Close, refresh, and delete customer 150. And let's take a look at the event log. So I have deletion of customer 150 with inversion of control, and then modification and creation. So that was it. So very similar to Facade, only way simpler. So instead of having all of those long methods which stuff things into a temporary table and then pass that table all around, I just have interface. So interface handles that. This is just one of the possible patterns that you can use to actually decouple the application. If you do stuff like that, do you think you would positively affect the time on your upgrade projects? Is there anybody who thinks no? Is there anybody who thinks yes? Okay, good. So the point that I'm trying to make here is that when programming something, what belongs to the business logic of the customer, something which is moving data from table A to table B, it should be CAL. Everything else, like any kind of domain logic which doesn't have anything to do with data in NAV, or which is processing data in NAV, you should put outside into separate assemblies, make interfaces for those classes, and use this inversion of control pattern. And see for yourself how you're going to benefit on the upgrade projects, or all of the projects. So this is how the code is decoupled. And this is basically how .NET people are writing software for quite a while. And we are still in stone age of like having tightly coupled code with the environment which is forcing us to do that. Facade pattern is powerful, it helps you. Now with .NET it's even more powerful, but there is a big overhead with that pattern. So you can simplify that with .NET by using inversion of control, which is kind of a little bit more modern than Facade pattern. And now one simple tip that I'm going to give to you is how to deploy easily to global assembly cache. So I've shown that string that I've copied from my Visual Studio into NAV, and I said that I'm pulling it out of my sleeve. Let me explain what I've actually done there. So There are two ways to deploy assemblies. One is in the end-in folder, another is in the global assembly cache. Both have benefits, both have drawbacks. Depending on what you need to do, you will choose either one or the other. I personally prefer using global assembly cache because it makes stuff more manageable, especially for inversion of control. It's much easier to locate stuff. To put something into global assembly cache, the assembly must have a strong name. So there is a very simple way to put a strong name onto your assembly, simply by going into the properties of your project, and then you click signing, and then you click sign the assembly, and then you create a new key, or reuse an existing key that you have. Make sure that only you have access to that key. Nobody else should, or actually your company does. So this is signing the assembly with strong name. This is the prerequisite for putting the assembly into global assembly cache. When you put the assembly into global assembly cache, it becomes visible to all of the applications, including NAV, without any special redeployment. So if I go here into wrong object, just a second. Let me take a code unit. So here I have this TechDays2013. I have picked it from my global assembly cache. This .NET is my global assembly cache. So I've picked it from there. So I've pulled this TechDays2013 assembly from here. And to put it into there, you have to call GACutil utility, which actually puts an assembly into global assembly cache. Typically do that manually, but here is the trick. So I'm actually always putting it into global assembly cache and reinstalling it in the global assembly cache with every build. So what I do here is I use post-build events, and I write this. Again, you may take a picture if you want. It's already available on my blog. So here, let me make it bigger. So what do I do is basically I first call the batch file that the .NET, Visual Studio.NET command prompt is calling every time when you start it, to make references to all of the .NET utilities, including GACutil. So I first call that. I, of course, do not know this by heart, and you should not know this by heart. There is an easy way. So command prompt. Here is my developer command prompt. So what I do is I go to the file location, I right-click properties, and I copy this target. And then simply put it in my post-build event like this. And then I delete this part, replace it with call, and delete this. And that's it. So it makes these GACutil commands possible. Then I call this GACutil with the project assembly name, and this one actually installs it in the global assembly cache and forces reinstallation. And the second one actually lists my assembly from the global assembly cache, and what it does is actually prints this thing. This is fully qualified assembly name. By just knowing this string, you can dynamically load that assembly on demand, on the fly, from global assembly cache when you need it. So I, for example, needed it in my inversion of control example. So that's this simple trick. It will save a lot of hours of manually copying files back and forth. So use that. And we are pretty close to the end of the presentation. Today I'm not skipping any slides or any concept because I don't have another presentation to fill in. So I have to complete here with one more small part. I'm going to discuss client-side deployment. Who has used client-side.NET? Okay, so you know that every .NET variable can be server-side or client-side. So when you put a .NET variable on the server side, it runs on the NST. When you make it client-side, it runs on the client. And there are certain considerations that you have to make, but let's not worry about them. Let's think of the situation that you actually want to make sure that every client who is connecting to your application is actually has access to this DLL. Because if you have a client-side control, then not only it runs on the client, it is instantiated on the client from the assembly which resides on the client, which means that if you have a custom assembly, you must deploy it to all of the clients. So imagine that you install 15 new computers, you need to also deploy on each of them this DLL. So this might be a hassle, it might cause problems. So let's take a look at a situation at what happens when we have or when we don't have a client-side assembly. So here I will start with a simple code unit. It's demo 13. So what does this code unit do? I have this class which is called foo, and I have foo server, which has run on client no, and I have foo client, which has run on client yes. So what I'm doing here is I'm assigning some context to this server-side foo, and then I'm saying that foo client equals foo server. Okay? Actually, I don't know why I did that. Let me copy this in there as well. And then I'm printing the content from this class, the client-side class. So what happens here? I first get an error which says cannot load type. So it tells me on my client machine I don't have this assembly. So I cannot compile freshly added piece of code which references that. And also if I try to run this client server, it asks me, do I want to do that? I say okay, and then it fails because it cannot create an instance. So I don't have an instance of this class. So typical situation in production, whenever you install a new machine and you need to use a custom .NET type library, you would encounter that if you didn't manually deploy it. So let's first manually resolve this issue. What I'm going to do here is actually take this DLL file. I will intentionally not deploy it in my global assembly cache. And here I'm going to just deploy, I'm copying that into my role-tailored client folder. So if I try to if I copy this again, and if I run that now, it will happily run. So what has happened is that on my client side, I have basically serialized the content of my server side object and basically created a new instance, and I'm running now this new instance. So I have successfully deployed this DLL. So why should we manually deploy the DLLs? Is there a specific reason for that? Why wouldn't we automate that process? So let me actually close my clients because I want to delete this one. So I'm deleting it. Okay. And then I will restart. Actually, I don't need to restart the service tier. I will just run my development environment and role-tailored client. However, let me run role-tailored client as administrator. I will explain why. It's demo 14. I forgot to announce it. So here I have one button, or actually action, which is called deployment test. When I click this action, what will happen is that basically it calls this code unit, auto deployment. So first part is equal, like I instantiate the server instance of this foo, I assign the context, and then I call if can load type, the client type. Sorry, if not can load type, which means the type does not exist on the client machine. Then I ask, the assembly is not present on the client machine. Do you want to automatically deploy it? How about that? And then if I say yes, it calls deployment management and it deploys to the client. Okay? That's why I wanted to run this as an administrator, because only administrator can deploy assemblies into program files folder. And then after this piece of code, in the same call where this type was not available initially, I assign it from the server and then print it out. So let's run this by clicking this action. So I click deployment test. It tells me, do I want to deploy it? I say no, intentionally, because I want to see the error. So first it asks me, do I want to do this? I say yes, okay. And now it fails because the type is not there. And then let's take a look at this folder. And let me run it again and say yes. And it runs. And if I run it again, it just runs. And I can verify that the assembly is deployed automatically. So let me show what is happening in under the hood. It's this. It's actually a lot of work. It doesn't seem like too much code, but there are actually as many different variables as there is code. And all of this is pure .NET. So what I do here is basically this is CAL. So here I retrieve the auto-deployment setup, which is simply telling me where I keep my assemblies, where they are stored, the folder. With some tricks, I could have just used my runtime assembly and passed it on, but I didn't. It would really be dirty, so I wanted to show a simple example, and if you want to get dirty, you can. Here what I do is I get the type from the variable that I want to instantiate. Then I get the assembly from the type to see in which assembly this resides. And then I get the file name of the assembly. So I know what is the file where this assembly is. This is still server end. Then I open the path to that file and I read the file into memory stream. And I copy this, I instantiate the memory stream and read the file into this memory stream. Then I convert this memory stream to base64 string, which I pass on to the client end. On the client end, I instantiate a memory stream by reversing this base64 back into binary array. And then I see what is my running assembly, which is my role-tailed client, and I need it because I need to know what's the path where I need to put the DLL. And then I basically save the assembly into that location. So I copy, here I open the file, and here I simply copy the memory stream containing the assembly into the file and close the stream. So when this method completes, this one resumes, and at this point, even though at this point I didn't have the type, at this point the type is already there. And once again, it automatically loads it. And now forever it will be there. So if you apply that pattern to your projects, then you will never have to worry about which types you forgot to deploy. You just add a simple function at the beginning of every object that uses your types. Or you might have one method which happens on company open, which checks if the client has all the required assemblies, and then you just deploy those which need to be deployed, and that's it. So with this, I conclude my part. Now it's your turn. Yes? Sorry?
What about dependencies of the assembly which I'm deploying inside?
Yeah, that's a very good question. That's something that you would have to do to extend this framework. So basically the question was, what about the dependencies? Because this is a very valid question. Like this DLL might depend on 5 other DLLs, and this framework will not copy it automatically. But then again, you can deploy all of them. So you can extend the dependence, this assembly setup. You can basically create a record which contains the list of all assemblies. Sorry?
Updates?
Again, you could add a flag which is called force update, and then it would update or something like that. So you could modify this framework to make it handle. Those situations are not that tricky. So you could easily manage all of the updates or deployments or anything else. Any other question? Actually, I have, for some reason, only 4 T-shirts today. So, Camille, did you already receive? You have one. Okay. You don't need another one. So, I have a question over there.
Yeah. If I have understood you right, in order to deploy the add-in, the client must be running in administrator mode?
Yes.
Okay, so is there any workaround around that? Or?
There is a workaround. It's a very dirty workaround to basically not even have any types on the client end installed at all, and to always instantiate types from assemblies created on the fly. So we would basically stream the assembly using the same concept onto the client end, instantiate it in memory, and then instantiate from running assembly. That's the workaround.
Okay.
I don't recommend it because it's, you know, funky reflection going on behind, and I don't know how well CL supports that, but that concept would also work. But unfortunately, to actually save a DLL into either global assembly cache or add-ins folder, you have to actually have administrator rights. I think you deserve a shirt. So,
there's another question here.
There. You're welcome. Another question, yes?
Yes. What about disposing types? How CRL handles it? I mean, some kind of streams, because in .NET we should dispose it explicitly.
That's a good question. So basically, for all of variables, the .NET Interoperability framework actually does disposal for you. So it is aware of the iDisposable interface, and it will call dispose whenever needed on all the variables. And then depending on whether the variable is local or global, you have a property which says, do you want to suppress dispose or let it get disposed? So for example, this is global variable, so it's always disposed when the object goes out of scope. So when this code unit goes out of scope, the .NET Interop will just call dispose for all of disposable types used in here. And for any locals, like here, you have suppress dispose. So this suppress dispose is in there so that the system can detect whether, or actually, imagine that you have local variable which you assign to a global variable. So local function goes out of scope, .NET Interop would actually try to actually call dispose on the iDisposable of that type. And if you set suppress dispose, it would postpone that, because for some reason .NET Interop is not keeping track of any external relationship, or basically the assignments or other references apart from the scope in which you are. So that's why you have this suppress dispose. I hope this answers the question. I'm not okay.
That's clear for dispose.
Sorry?
That's clear on a variable called dispose.
You mean when you call clear and the variable? I suppose yes, but I'm not quite sure. I would be quite surprised if it didn't. Yeah. Actually, does this question deserve a shirt? Okay. There we go. And one more. Make it a good question. It was also good, but make it better. Yep.
Don't you have to take care of the platform if you have a client platform 86 and you have a server 64?
Yes, you do. You do need to care about it. I mean, we're talking about deployment stuff. Yes, you wouldn't be using a 64-bit assembly in that way. So this can be done only with 32-bit assemblies. Or, I mean, at least assignment. But auto-deployment, it doesn't care. I mean, I've just shown auto-deployment in this example where basically I'm using a type and I'm immediately detecting if it's there and then deploying if it's not. But you could just use deployment framework apart from assignment of variables. So you cannot assign a 64-bit variable to 32-bit because it's not the same type. They're not type compatible. So it's just like trying to assign string builder into date time or something like that. So that would not work.
Okay, you also mentioned you can deploy to the global assembly cache, but you have to add the code to...
So you mean like auto-deployment to global assembly cache? You could manage that as well. So you could, for example, store an assembly into some folder on the server where you could write without administrator rights and then call gacutil, for which again you need administrator rights. So you cannot get rid of that. But you could deploy to GAC as well. So no limitations. Yeah.
Right. I already have a t-shirt, so you can...
You have? Okay. But it was a good question. Anybody else? Any more questions? Over there. Okay. Yep. Yes. And you'll return the shirt if it's not a good question. Well, give it to somebody else then. So whoever has a shirt is not entitled to ask questions. So
Sorry. I don't often do this in .NET. I know you can write code in a string and then compile it on the fly.
yes,
Is that also possible?
yes, I've shown that last year here. There is a demo on my blog and on my booth, so it's called Generic
yes.
Web Service Caller. So it basically does that. So it
I was there.
constructs the code on the fly, compiles it into the assembly, and then loads this assembly dynamically to user reflection to instantiate types. So, yes.
So
I was thinking of showing something similar to this here when talking about try-catch, like constructing on-the-fly type-catch classes of specific type, so you don't have to have the helper. Just didn't have time, but it would have been a better demo. But
because it was last year already explained, and I was there, and so I apparently forgot. It wasn't a good
it's
question.
okay. Yeah.